Section 7.5 is on page 461, talks about partial fractions. I'm giving this lecture a whole day by itself because I really need to get this out of the way, something that's not going to go away, you really need for later on math courses. And let me start really simple with what we're doing. If I get a common denominator, so this is 2x minus 5 over x minus 2 into x plus 1. That's really what it is. Well, guess what? We want to go backwards. We are given this, and we're given this in this form even. And we're trying to figure out where this came from. So that's what we're doing, and if you glance, that's how all the problems look. So, here's the deal. First, we need to really get proper fractions out of the way. We have a proper fraction. A over B is proper if B is greater than A, and of course, B doesn't equal 0. So B equal 0 is not going to come out. Now we're talking about polynomials. We're going to apply this idea of proper. It's not really a definition, but we're going to talk about what's kind of like proper rationals. No such thing. Proper rationals is when you have f of x over d of x, in which the degree of d of x is greater than the degree, the power, of f of x, so to speak, because otherwise this technique doesn't work. So if I look at problem number 2 on page 466, I'm going to show you how the book does this, and I'm going to show you how we're going to do this. So the book says, alright, write this as the product, so factor. And this would be x, let me see, 54, 6 times 9, 9 and 6. And this is 3 into x minus 3 divides 8, 2 times, you have 29. Okay, so the deal is, we're trying to figure out where this came from. You need to list the possible combinations you could have gotten that denominator. In this case, it's straightforward, x minus 10, x plus 6. And this is how it works. We need those to be proper. For this to be proper, I need the top to be, the degree of the top, to be less than the bottom. So, if the bottom is linear, constant is just a letter, A, B, C. Linear equation is really AX plus B. That's a linear equation. Quadratic is AX squared plus BX plus C. So when I say the top, to make this proper, the top should be 1 power less than a linear, I'm saying the top is just a constant. And this is just a constant. So the book, the way they do it in the book, they use systems of equations. We have a much more efficient way. The way they do it in the book, they say, look, those two are equal. Clear the fractions. 3x minus 87 equals. Get a common denominator on the right. So wouldn't that be a into x plus 6 plus b into x minus 9? And this is where we're going to differ from the book. The author says from this point you would get rid of the parentheses. And the author says get the x's together, get the constants together. If I want to take the x's, that will be a plus b. And the terms with no x are 6a and a minus 9b. And then they say, well, look, those two are equal. The only way those are equal, if the number in front of the x equals the number in front of the x, and they come up with a system of equations. They say a plus b must equal the 3. And the terms without an x, those would be the constant, must equal the 6a minus 9b must equal the negative 87. And that's how they do all the problems. They force the coefficients to equal, and that makes sense. If you put a 3 right there, that will be 3x, matches, and if you put negative 87 there, it will be the same. And now what? You could multiply the top equation by a negative 6, say. That becomes negative 6a minus 6b equals negative 18. You could add those, and that's negative 15b equals a negative 105, and b will equal a negative 105 divided by 15, which is divided by 15, what is that? Okay, if I divide by 5, the top is 21, the bottom is a 3, that's a negative 7. And if I know that b equal negative 7, then I'll say a minus 7 equal 3, a equal a 10. Well, guess what? I just figured out where this fraction came from. If you add those two, you will get this. This is how the book does it, and that's fine. There's nothing wrong with that. Let me show you how we're going to do it. This is what we're going to do. We're going to actually take this and we're going to say, look, this is our shortcut. Isn't that an equation? What's the domain? X cannot be a 9. Let x equal 9. But you're not allowed to do that. Let x equal 9. You'll get this equation. You'll get 3 times 9, 27, minus 87 equal a. If you put a 9 right there, isn't 9 plus 6, 15? And if you put a 9 there, isn't that a 0? And if you subtract those, negative, what is that? 0, 60 equal a times 15. That means a is a negative 4. Okay, how come it's not matching? Let me just double check. X equal 9, 9, 15, 9, 27, 60, negative 4. Okay, and if I let x equal, what's the other value you can't have? You can't have a negative 6, not in the domain. Let x equal negative 6. If you put a negative 6 right there, 3 times negative 6 is negative 18, minus 87 equal. A negative 6 there will make that a 0. A negative 6 there will make that b times negative 15. And this is 15, 8, negative 105. So I'm getting b to be a positive 7. Let's see what went wrong. Yeah, right there. Isn't that negative? I forgot it. This should be a positive 7. And if this is a positive 7, this is a negative 4. So there. You see how simple that works? A would be a negative 4. And B will be a 7. And that's how we're going to do the problems. So the book does it this way. We're going to proceed this way. We're going to use the book's method on certain problems, but this is going to help us nevertheless. And it's a lot more efficient, I think, and a lot nicer in so many ways. You know what, let me leave it like that. It doesn't look pretty, but that's okay. The first example, never a problem. I'll leave some space, and I'll come back and do some more. That was really messy. Okay. Okay, problem number 4 is next. We want to do the same thing. We're going to say, well, that is negative x squared plus 2x minus 14 over x plus 3. And if this factors, isn't that x minus 2 squared? So this is the least amount of work I could do. If you see a repeated factor, you have to list it at least that many times. That's the bare minimum work. So I have to list it that many times at least. And I'm going to make a couple of problems up because there aren't enough problems in the book, but that's not a problem. So here I'll say, well, alright, this is linear, this is A, because it has to be proper. This is linear, that's B. Now, even though this is quadratic, but since I can write that as the product of linear factors, it counts as linear. So here the game becomes, how quickly can you find A, B, and C? The book's method will have you solve 3 by 3. Our trick will allow you to get to the answer in no time. This is how we're going to do it. We're going to clear the fractions. We do that either way. The LCD is right there. So we multiply by whatever each of those is missing. You're going to have to do that whether you're using the book's method or our method. I like to call it a shortcut. And watch how quickly this works. Again, I'll show you what the book does, and you could decide on your own. So what we're going to do, we're going to say, what's the domain? The domain, x cannot be negative 3. Let x equal negative 3. That will be a negative 9 minus 6 and a minus 14 equal. If I put a negative 3 right there, A, isn't that negative 3 minus 2? Negative 5 squared is 25. Do you see if I put a negative 3 there, that will be a 0, and a negative 3 there, that will be a 0? And isn't this negative 29 equal 8 times 25? So A is negative 29 divided by 25. Let me make sure. Oops, I messed up. Oh, no, I didn't. Let x equal negative 3. So negative 3 squared, that's 9, negative 3 minus 6 minus 20. Yeah, okay. So A happened to be negative 29 divided by 25. Okay, I could put that in there. And do we see that another value we can't have is 2? Well, guess what? Let x equal 2. A 2 in there, that's a negative 4. A 2 in there plus 4 minus 14 equal. A 2 in there will make that a 0. That's going to happen all the time. A 2 in there will make that a 0. And a 2 in there will make that 2 plus 3, 5c. And doesn't this indicate that this is negative 14 equal 5c, which means c is negative 14 over 5? Now, here comes the trick. I ran out of numbers. I used both numbers and I didn't get to the answer. You could let x equal anything. This is an equation. Isn't it easy since I used negative 3 and 2? Anything other than that. How about 0? Put 0 in for x. Isn't that negative 14 equal? If I put a 0 right there, isn't that negative 29 over 25 times, isn't that a 4? If I put a 0 right there for x, wouldn't that be b times negative 6. And if I put a 0 right there, isn't that minus 14 over 5 times 3? So I'm looking at negative 14 equals negative 4 times 36, 8, 116 over 25 minus 6b equals negative 42 over 5. Clear the fractions, minus, not equal. Clear the fractions, the LCD is 25, so negative 14 times 25, backwards. 20, 10, 5, 2, 350. Negative 116, 25 times 6 is 150, and times 5, 42, that's 210. So this is negative 350 equals negative 426, I think. Yeah. So that means, what is that? 5 out of 70. So B equals negative 76 over 150 divided by 2, that's 75. Divided by 2, what is that? 38, is that right? The numbers are not nice, but there it is. Now what's the alternative? The alternative is they take this equation. Let's use, they take this equation as is. This is how they do it in the book. And they say, not this equation, you have to do this no matter what. They say clear the fractions, clear the parentheses. This, isn't that a into x squared minus 4x plus 4 plus b? Isn't that x squared plus x minus 6 plus c times x plus 3? They say if we get rid of all the parentheses, you're looking at negative x squared plus 2x minus 14 equaling ax squared minus 4ax plus 4a plus bx squared plus bx minus 6b plus cx plus 3c. And then they say, look, let's get the squares, let's get the x's, and let's get the none. The ones that don't have any of those. So here, let me push this up. Let me push this up. And let me push this up. So, if I look for what's going to go in front of x squared, that is a plus b. That's it. And if I'm going to go for what goes in front of x, negative 4a plus b plus c. And if I go for the constant, 4a minus 6b plus 3c. And out of this they come up with 3 equations. They say the number in front of x squared must equal the number in front of x squared. I'm going to leave some space. And they say the number in front of x must equal a 2. Does this look familiar? And they say the constant must equal the constant. And they solve this system of equations. And you know how much fun that is. This is a lot more efficient. Since they're doing all the problems using that trick, using the systems of equations, that's why they don't have a whole bunch of problems for you. Okay, number 6 is next. And if I glance at this, this says 3x squared minus x minus 4 over, I could factor an x out of that. That would be x squared minus 2, right? And I'm going to even take it a step further. Something that we normally don't do, but we're going to do it anyways. We're going to say this is 3x squared minus x minus 4 over x. Isn't that x minus radical 2 into x plus radical 2? And we're going to say this fraction must have came out of and since that's linear, that's a power less, linear, a power less, and since that's linear, a power less. All what I need to do is find A, B, C, and I'm done. Clear the fractions. And it's fairly simple. Let x equal 0. Isn't that the domain right there? Let x equal 0. I'll get 0 plus 0. I'll get a negative 4 equal a. A 0 there and a 0 there. I'll get negative radical 2 times positive radical 2, which is negative 2. A 0 there will make that a 0, and a 0 there will make that a 0. And guess what? A is 2. What a nice problem. Let x equal radical 2. Not a pleasant number. That's okay. If you put a radical 2 in there, you will get 3 times radical 2 squared is a 2, minus radical 2 minus 4 equal a. If you put a radical 2 there, that's 0. If you put a radical 2 there, that will be b times radical 2. A radical 2 plus radical 2 is 2 radical 2. A radical 2 there will make that a 0. So that would be 6 minus 4 is 2 minus radical 2 equaling, and if you multiply those, isn't that b times 2? Radical 2 times radical 2 is 2 times 2 is a 4. So b is 2 minus radical 2 over 4. And to find c, all what we have to do, choose the last value. We let x equal negative radical 2. That's what make that 0. And what do we get? 3 times 2, which is 6, minus a negative is plus radical 2 minus 4 equals a 0, because negative radical 2 there, a 0 plus c times negative radical 2 times negative 2 radical 2. That would be 6 plus 2, that's 2 plus radical 2 equaling negative times a negative is a positive. Radical 2 times radical 2 is 2 times 2, that's a 4. So c is 2 plus radical 2 over 4. And there it is. That would be the answer. You just want to figure out where did this come from. And we have one more to go, and this is the toughest. And I'll show you how you'll know that this is the worst. This is the toughest because our shortcut doesn't work on this. And do you see why? The denominator is already factored. So I'll say this is, it must be x squared plus 7 and x squared plus 7 squared. Now, do you see that this is quadratic? And I can't factor that, so the top has to be 1 power less. And do you see that this can be written as x squared plus 7 times x squared plus 7? So it only counts as 1 quadratic. And in this case, I have no choice. We always clear the fractions. We have to use the Book's method in this case. And wouldn't that be ax plus b times x squared plus 7 plus cx plus d? And since I can't make those 0, there's no point in plugging numbers. I could let x equal 0, but that's about it. So what I'm going to do, since I have no choice, I'm going to follow the Book's trick on this case. That's going to be ax cubed plus 7ax plus bx squared plus 7b plus cx plus d. I'm going to say 3x cubed plus x squared plus 22x plus 3 equals ax cubed is 1 of a kind, bx squared is 1 of a kind, right? If I want to go for x, 7a plus c, and if I can go for the constant, 7b plus d. What does this tell me? This tells me that the number in front of the cube must equal the number in front of the cube, the number in front of the square must be a 1, the number in front of x must be a 22, and the constant must be a 3. Meaning, a equals a 3, I got it. B equals a 1, I got it. And doesn't this say 7a plus c must equal a 22? But I know this is 3. 3 times 7, 21 plus c equals 22, so c is a 1. And isn't 7b plus d equal a 3? But I know what b is. They don't always work out this nicely. This author is very gentle and nice. So here you're going to say it's a plus b cx plus d. So this is where this fraction came from. And in calculus, you need to be able to do that. That's the answer. And your homework is on page 466. You're going to do 1 through 13, odd skip number 11, and on page 478, 21, 23, and 25.